Today's lesson objective, students will prove theorems about perpendicular lines. So our first theorem says if a linear pair is formed by congruent angles, then the lines are perpendicular. And if you stop and think about it, it makes sense. If we were adding our angles together, they would have to add up to 180 because linear pairs are supplementary. And we know that if they're congruent, the measure of 1 equals the measure of 2. And so if I do substitution, the measure of angle 1 plus the measure of angle 1 equals 180. I end up getting that 2 times the measure of angle 1 is 180. Therefore, the measure of angle 1 is 90. So if angle 1 and 2 are both 90 degrees, then that's what it means to be perpendicular. So the lines would be perpendicular. So if you have a situation where angle 1 is congruent to angle 2, then you know that in this figure, line G is perpendicular to line H. The next theorem, give myself a little more room here. The next theorem states that perpendicular lines form 4 right angles. And this makes sense also, because if I have one right angle, so suppose that I just started with angle 1 as a right angle, that's 90 degrees. 1 and 2 are a linear pair, so that would have to be 90 degrees. 2 and 4 are a linear pair, so that would have to be 90 degrees. 1 and 3 are a linear pair, that would have to be 90 degrees. So it makes sense. Not just one right angle is formed, but 4 right angles are formed. So if A is perpendicular to B, then angle 1, angle 2, angle 3, and angle 4 are right angles. All right, and our third theorem that we're going to learn is if non-shared sides of 2 adjacent angles are perpendicular, then the angles are complementary. So our non-shared sides in this figure are AB and BC. So basically the information that you would have to be given first of all is that BA, rather, it's a ray, so ray BA is perpendicular to ray BC. And if you're given that information, then you can say angle 1 and angle 2 are complementary. Okay, so just to summarize and repeat, if a linear pair is formed by congruent angles, the lines are perpendicular. Perpendicular lines form 4 right angles. And if non-shared sides of 2 adjacent angles are perpendicular, then the angles are complementary. So we're going to actually prove that last one on the next sheet. And so you can see here, we're given BA is perpendicular to BC, and so you'll recall the given is what comes from the hypothesis. Non-shared sides of 2 adjacent angles are perpendicular. That's the general statement. Here is a specific one to do with the picture, so that's what we use for the given. And then what we're going to prove comes from the hypothesis that the angles, the conclusion, the conclusion. The angles are complementary, and then more specifically for this figure, 1 and 2 are complementary. So that's where the given and prove come from when we're proving a theorem. All right, so we start off with BA is perpendicular to BC, and that was given to us. So if they're perpendicular, what does that mean about angle ABC? Well, it means that angle ABC is a right angle. So, and that's just either the definition of perpendicular lines or perpendicular lines form four right angles. Since we only have one right angle, we can use the definition there if you want to as well. And you could also say given in the figure, since they have the mark, the right angle mark there. Okay, so let's think about where we're going. If angle ABC is a right angle, then that means it equals 90 degrees. And since 1 and 2 are the two pieces of that angle, then they should add up to 90 degrees, which is what it means to be complementary. So that's where we're going with the proof. We're going to start off saying that the angle is 90 degrees. We're going to use the segment addition postulate and then substitute. So if ABC is a right angle, then what does that mean? That means the measure of angle ABC is equal to 90 degrees. So instead of saying is, we'll use an equal sign there. And how did I know that? Well, that's what it means to be a right angle. So it's the definition of a right angle. And I'm trying to get to where 1 and 2 add up to 90 degrees. I can't say that yet, though. First, I have to say that the measure of angle 1 plus the measure of angle 2 is going to equal the measure of ABC. Because the two pieces add up to the whole thing, that's the angle addition postulate. And now, because ABC equals 90, I can substitute that in. I can say the measure of angle 1 plus the measure of angle 2 is equal to 90 by the substitution property of equality. And therefore, I know 1 and 2 are complementary because that's what it means to be complementary. It's the definition of complementary angles. All right, so now I no longer have to go through all those steps. If I'm told that I have perpendicular lines, right off the bat, then I can say that the angles are complementary. So let's look at another proof here. You might want to pause the video and write it down. All right, so we're going to start off, we're given that angle 1 and angle 2 are congruent to each other. And we want to prove that 3 and 4 are complementary. So if I can say that the lines are perpendicular, then I know 3 and 4 are complementary because of the theorem we just proved above. So angle 1 is congruent to angle 2. You were given that information. And one of the theorems that we just had on the previous slide was that if a linear pair is formed by congruent angles, then the lines are parallel, or perpendicular, excuse me, then the lines are perpendicular. So that means I can say the lines are perpendicular. I can say that QV is perpendicular to PS because 1 and 2 are congruent to each other. Now that I've said the lines are perpendicular, that's all the information I need to say that 3 and 4 are complementary because of the theorem we just proved above. If sides of adjacent angles are perpendicular, then the angles are complementary. Okay, we've got a couple more theorems to discuss. First one we'll talk about is the perpendicular transversal theorem. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So what you would have to be given in this situation is if line J is perpendicular to line H, and line H is parallel to K. If you have those two things true, then you can say that J is perpendicular to K by the perpendicular transversal theorem. Next one is very similar to it. It's lines perpendicular to a transversal. If two lines are perpendicular to the same line, then they are parallel. And really, this is just a corollary to the corresponding angles postulate, because you can see my right angles are corresponding angles. If M and N are parallel to each other, or if M and N are both perpendicular, they're both right angles by the converse of the corresponding angles postulate, you can say that the lines are parallel. So if you're given the information that M is perpendicular to P, and you have to also be told that N is perpendicular to P, then you can conclude that M is parallel to N. All right, so looking at this figure, let's see if we can figure out which lines are parallel. Pause the video for a moment, see if you can figure this one out on your own. Okay, so if I look, I can see that I have two right angles right here and right here. So line A and B are both perpendicular to line S. So that means that A has to be parallel to B, because they're both perpendicular to line S. Then if I look at these right angles, S and T are both perpendicular to line B. So S and T would have to be parallel. And then, so let me go ahead and mark my parallel lines then. These are parallel. And these are parallel. So now that I've said that S and T are parallel to each other, I know that T is also going to be perpendicular to A. Because I said A and B were parallel. And because B is perpendicular to T. And again, if you just even think of it as corresponding angles, you could look at it as corresponding angles, or yeah. So can I say anything about line U? Do I have any information about line U at all? I don't, so I can't make any conclusions about line U. Even though it looks like it's parallel, it might be just slightly off, in which case it's not. So you can't make any assumptions there. All right, this concludes the video. Thank you. Yeah.